Hi all. So today we'll be focusing on integrating trigonometric functions. So our goal for this lecture and probably the next lecture will be how to integrate this sort of functions: cosine to the 5x dx, sine to the third, cosine to the 7x dx, tan to the 4 dx, and the last one is this. So the main tools we'll be using to tackle these integrations are trigonometric identities, U substitution, and reduction formula. So the trigonometric identities that will be useful in this case are like sine square x plus cosine square x is 1, tan square x plus 1 is secant square x, and 1 plus cotangent square x is cosec square x. Yeah, and probably some others which can be deduced from these three. So yeah, let's move. So these integrations are something that you know already. What is the integration of sine x, cosine x, secant square x, and secant x tangent x? Okay. And moreover, we need this integration and this. Okay. So all of these integrations can be like reduced from U substitution probably. So for example, if I want to prove this result, tan square x dx is ln secant x plus c, what we have to do is like, so you'll write tan x as sine x over cosine x dx, just like here. And then we can use U substitution. Let U is cosine x dx, cosine x, cosine x. Then du is minus sine x dx, right? And if we substitute, then I'll have U on the bottom, and this implies sine x dx is minus du. So I'll have minus du on the top, okay, which is minus ln u plus c. Now u is cosine x, so minus ln modu actually. So minus ln modulus of cosine x plus c. And this is nothing but ln secant x plus c. Cool. By using the property of ln. So likewise, the others identities can be also proved. Okay. Now, so to start with, let's focus on this example. Sine to the 7x cosine x dx, how to tackle this. So this can be done using U substitution. This is quite easy. So suppose I take u to be cosine x. Oh, sorry. If I take u to be sine, then my du would be cosine x dx, right? And now if I substitute in my integration, I should have u to the 7 and then just du. So this is e to the 8 over 8 plus c, which is nothing but sine x to the 8 over 8 plus c. Okay. So this is not that difficult. Okay. Now if I try to go to generalized integration, where you can have integrations like this: sine to the mx times cosine to the nx dx, where your m and n can be any number. I mean, integer to be more precise. Okay, so the strategy to do integration for this sort of functions will be, if you find among this m and n, if you find at least one of them is odd, then we'll be using strategy 1. So if I found m is odd, then I'll not look at n anymore. I'll just use this strategy. What I'll do, I'll save one of the signs and convert the remaining signs into cosines using this identity. Sine square x is 1 minus cosine x. And then I'll substitute u as cosine x. Okay. So probably one example will be like helpful in this case. Okay, I just shift everything. Let me add one page. Yeah. Okay. Okay, cool. So let me do one example right here. So if my integration is like this, sine to the 3x cosine x dx. Okay, so you can easily see that my m in this case is 3, which is odd. So I can use strategy 1, right? So therefore, what I'll do is I'll save one sign. So therefore, let me save one sign like this, sine square x, and this sine x is like saved. Okay, and then convert everything into cosine. So I know that sine square x is this. So what I'll do is I'll just convert this sine square into 1 minus cosine square x. Okay, so as this is a test example, let me do something more like difficult. Say I have sine to the 5x. Then I'll have this, right? So, and this is nothing but sine square x whole square, right? So therefore, I'll have 1 minus cosine square x whole square, cosine x sine x dx. Okay, so far so good. And now I need to convert, I need to use substitution u to be cosine x. Let u is cosine x. Then du is just minus sine x dx. Right? So therefore, this becomes integration 1 minus u square whole square. And then you have one more u there. And sine x dx is minus du, right? So I have minus du there. Okay, cool. So this is 1 minus 2u square plus u to the 4 times u du. I can pull that minus outside. And this is just minus 1 plus 2u square plus u to the 4 times u du. You pull this further. And this is minus u plus 2u to the 3rd plus u to the 5th du. I just multiply u inside. And I can do the integration now, right? So u square over 2 plus 2u to the 4 over 4 plus u to the 6 over 6 plus c, which is nothing but, so my u was cosine x, right? So minus cosine square x over 2 plus cosine to the 4x over 2, cancelling 2 and 4, and cosine to the 6x over 6 plus c. Okay. So using strategy 1, we can do the integration like this. Okay, cool. Next, focus on oh, I miss. Oh, yeah. So next, on the other part of the strategy 1, if I find n to be odd, okay. So let me do one example of this kind. Right there after the strategy. Okay. So if I have something like integration sine x and then cosine to the 3x dx like this. So here my n is 3, which is odd. So therefore I can use this strategy. It says save one of the cosines. So like just like the previous one, I write cosine square x like this and then one more cosine x dx like that. And then convert the rest into sines. So I have cosine square x. I will convert it to sine like this. And one more sign is left behind. Let's write it out. And then substitute u to be sine x. Then du is just cosine x dx. So then this becomes u times 1 minus u square du, right? Integration, which is just u minus u to the 3rd du, which is u square over 2 minus u to the 4 over 4 plus c. And then at the very end, just substitute sine x in place of u. So I have sine square x over 2 minus, okay, let me have some more space there. So this is nothing but sine square x over 2 minus sine square, sine to the 4x over 4 plus c. So this is your solution. Okay. Now, if your both m and n are even, then how will you tackle it? So then what you have to do is, sorry, you have to use the identity sine square x to be half 1 minus cosine 2x. And the other identity, this 2 you have to use. And then you have to write everything in terms of cosine 2x. Okay. This is one way. And the other way is you will use the other identity of sine and cosine, this 2. And then you will convert everything into power of sines or cosines. At the very end, you will use reduction formula. I'll come to reduction formula, what that is in a while. So let me not do this example because I have already done both of this. And how to apply strategy 1 is done. Yeah, but I can do this example. This is also an example of how to apply strategy 1. So this is, so in this case, so let me go back to strategy 1, sine to the m and cosine to the nx. Okay, so in this case, I can see that my m is 0 and n is 5. So this is odd. So therefore, I can use my strategy. So, okay. So I will separate one cosine, right? So I'm not, if I'm not too wrong, I'll separate one cosine like this, and then I'll use substitution u to be cosine x. Oh no, sorry. I'll use the substitution u to be sine x. Okay. So first, cosine to the 4 can be converted into 1 minus sine square x square, right? Because I know that cosine square x is just 1 minus sine square x. So cosine to the 4 will be whole square of 1 minus sine square x, and there is cosine x dx left over. Integration. Now u is sine x, so 1 minus u square whole square, and du is just cosine x dx. So you have du there. Okay. So this is 1 minus 2u square plus u to the 4 du. So you'll have u minus 2u to the third over 3 plus u to the 5 over 5 plus c. Okay. And at the very end, if you substitute u by sine x, then you'll have the result like this. Sweet. Okay. And this is the reduction formula for sine and cosine. So see that if you have sine to the n, then you can use this formula. The right hand side is involved again cosine to the n minus 2x dx. But if you have, say, n to be 4, then you'll use this formula, and this cosine to the 4x will be cosine square x integration. So you are just reducing down the power of cosine in the integration. That is basically the reduction formula, and why the name is like that. And the same kind of formula holds for sine. Okay, here also the same thing happens. Okay, now remember, we haven't seen any example of using this strategy 2. So here we'll use it. We'll show how to use it. Okay, so I have to use, so for this example, cosine to the 4x dx, there are two ways of solving it. One is, okay, opening this. Okay, so one way is you can use reduction formula straight away, and the other way is using the double angle formula, which is kind of strategy 2. Okay, so let me do it in way 1 first. So the way 1 is, I have cosine to the 4x dx, right? So my n is 4 in this case. So remember, this is my formula for, yeah, remember, this is my formula for cosine to the nx, the reduction formula. So 1 by n, so becomes 1 by 4. So I have sine x, cosine to the n minus 1 becomes cosine to the 3x. Plus n minus 1 is 3 over n is 4. Integration cosine to the n minus 2 is just 4 minus 2, just 2x dx. Okay. Which basically comes from this. Okay, cool. Taking n to be 4. Okay, now this is 1 over 4 sine x cosine to the third x plus 3 over 4. So cosine square x, again, I can use the reduction formula, right? But here my n is 2. So this will be 1 over n, so 1 over 2 sine x cosine to the 2 minus 1, so cosine x, right? And then plus n minus 1 over n. So I have 1 over 2 integration cosine 2 minus 2 x dx, right? Cool. So this is 1 over 4 sine x cosine to the third x plus 3 over 8 sine x cosine x plus 3 over 8. So cosine 2 minus 2 is cosine to the 0, and anything to the power 0 is just 1. So therefore, I'll have dx here. So this is 1 over 4 sine x cosine to the third x plus 3 over 8 sine x cosine x plus 3 over 8 x plus c. So this will be your final answer. Okay. So basically, you had to use reduction formula 2 times. Okay. Now, if I go by way number 2, it says use double angle formula, right? So I have cosine to the 4 x dx, right? Integration. Okay, so let me go back to strategy 2 once more. Yeah. Okay, so I'm talking about applying this one. So I'll use these two identities. Let me just copy it, and then so I have cosine to the 4, so I need this one. Copy, and then paste it. Okay, so I'll have to use this. So I have cosine square x whole square dx, right? Same thing. And now cosine square x is just by this identity half 1 plus cosine 2x whole square dx, right? This is 1 over 4, 1 plus cosine 2x square dx. Okay, I need space. This. Now, this is 1 over 4 can be written outside of the integration. And then the square formula 1 plus 2 cosine square 2x. No, 1 plus 2 cosine 2x plus cosine square 2x dx. Okay, so 1 over 4, 1 plus 2 cosine 2x is fine, but this square cannot be dealt right away. So therefore, what I'll do is just I'll use this formula once again. I'll use this formula. Once more. But here I'll use it with cosine square 2x. So this will be half 1 plus cosine 4x, right? Because when I have x there, oh, so when I have x there, I have 2x here. So if I replace this x with 2x, then I should have 4x on the right. Anyway, so this is plus half 1 plus cosine 4x. Okay. So I have 1 over 4 integration 1 plus 2 cosine 2x plus half, right? Plus half cosine 4x dx. And this is 1 over 4 integration. So half plus 1 is 3 over 2 plus 2 cosine 2x plus half cosine 4x dx. Now do the integration 3 over 2x plus there is 1 over 4 outside plus, so this will be 2 cosine, so sorry, 2 sine 2x over 2. How, if you do not get it right away, then use u substitution. Take u to be 2x and then reduce this to be a simpler integration and you'll find this answer at the end. Plus half, so this will be sine 4x over 4 by kind of the same logic plus c. So this is 3 over 8x plus 1 over 4 sine 2x plus 1 over 32 sine 4x plus c. Okay, so this is your final answer. Sweet. And the last example for today will be this one. When you have sine square x cosine to the 4x, so your m is 2, n is 4, both are even. Okay, so therefore, obviously, you have to use strategy 2. Strategy 2 has like 2 ways to do it. So I'll use the way where you have to use the reduction formula because that is kind of like easier for me to apply. So if you go to strategy 2, it says this one, I'm applying this one now. You have to use, maybe you have to use one of these two identities to make everything into either sine or cosine and then use reduction formula. So I have sine square. So like 2 is obviously less than 4. So therefore I'll use the identity over sine square and reduce that to 1 minus cosine x. And if you multiply cosine to the 4x, then you can see that in this integration, everything is in terms of powers of cosine. And then you can use reduction formula for cosine. Okay. Oh, sorry. What just happened? Okay, my screen is not anymore visible. Okay. I got logged out somehow. Just a minute. Okay, yes, now things are like, okay. So I had to use the reduction formula. So let me see if I can pull that down here again for cosine. So I have to use the reduction formula for cosine, so I'll pull only this. Best right here. So my n is 4 and n is 6. So I have to use for both of them. So this will be slightly longer. You have to use them like maybe 2 or 3 times. So I have cosine to the 4x dx. I'll not touch it. I'll not use the reduction formula right away. Why, you'll able to see it in a while. So 1 over 6 sine x cosine to the 5x no dx plus, so this minus will carry out, so I have minus 5 over 6 integration cosine in minus 2 is like 4x dx. Okay, so I have used the reduction formula for cosine to the 6x dx. So why I have not like used reduction formula right there, because now I can see I have cosine to the 4x dx and 5 over 6 cosine to the 4x dx. So I can like add this two kind of. So minus 1 over 6 sine x cosine to the 5x remains as it is, and then I can like factor integration cosine to the 4x dx from both of this. Then I'll have 1 minus 5 over 6, right, which is 1 over 6. So 1 over 6 times cosine to the 4x dx integration, and minus 1 over 6 sine x cosine to the 5x, right? And then you have to use reduction formula 2 more times. So this should be, the rest should be done by you. So this was more or less about the part 1 of how to do trigonometric integration. So I have like done how to tackle this kind of integration, how to tackle that. These two are like the remaining part, and I'll upload the lecture about those maybe tomorrow. Okay, cool. Thank you.